discuss about introduction to formal proofs. Basically, to learn a theory of computation, you are in need of to learn mathematical proofs. So, three different types of mathematical proofs are there. Next, that is proof by deduction, proof by induction, proof by contradiction. So now we are going to discuss about proof by deduction. So it is otherwise known as deductive proofs. So what are these deductive proofs is, we have to get the information from the known fact. From the known fact, we will get some conclusion. This is deduce and then come for conclusion. This is known as proof by deduction. So deductive proof can be defined as sequences of steps or statements, or otherwise known as initial statements. It is called as hypothesis. This known fact is known as hypothesis, and what we deduce from it is known as conclusion, or the given statement to a conclusion state. From hypothesis state we are moving on to conclusion state. So this is about proof by deduction. It is always referred as if H then C, if hypothesis then conclusion. If hypothesis is true, then the conclusion is true. This is the real meaning of proof by deduction. Let us see one example. If x is greater than or equal to 4, then 2 to the power of x is greater than or equal to x square. So we are going to prove this theorem using proof by deduction. So what is our hypothesis? If x greater than or equal to 4 is our hypothesis, 2 to the power of x is greater than or equal to x square is our conclusion part. Now let us check whether hypothesis is true. Let us take some value for x. X shall be given any some value. So if value is 4 only, it will be equal to 4. Otherwise, if you get lesser value, the condition will not be satisfied. At least 4. At least 4 means 4, 5, 6, 7, something like that. We have to give the value for x. X value is, let us assume x value is equal to 4. It can be, we have to check whether it is true. Yes. If it has lesser value, the condition becomes false. If I put 2, 2 is greater than or equal to 4? No, it is less than 4. So therefore the condition fails. Next. So let us put x value is equal to 6 there. So what happens? X value is greater than or equal to 4. Let us check. 6 is greater than or equal to 4. Yes, the condition is true. Therefore 2 to the power of x. X is greater than or equal to 4. What is 2 to the power of x is 2 to the power of 6. So it is 64. What is 64 is greater than or equal to x square. X square is 6 square, 36. 64 is greater than 36. Therefore we come to the conclusion that if the hypothesis is true, the conclusion is also true. If H is true for certain values and not for the other values. Right. Next. One more example is sum of square of 4 positive integer is true or not. We are going to check. If x is sum of square of 4 positive integers, then 2 to the power of x is greater than or equal to x square. Let us check. What is the hypothesis? Sum of square of 4 positive integer is hypothesis. What is our conclusion? 2 to the power of x is greater than or equal to x square is our conclusion. So let us assume 4 positive integers as a, b, c and d. So now what I have to do is, square of 4 positive integers means, positive means at least the value should be 1. Then only it is positive value. A should take the value as 1, B should take the value as 1, C should take the value as 1 and also D. At least 1 means A greater than or equal to 1. I can say B greater than or equal to 1, C greater than or equal to 1 and D greater than or equal to 1. When you add all this thing, you will be getting minimum value as 4, at least 4. So let us keep it as x. Initial step of hypothesis is true. Let us check. Next slide. See, this is the summarized value. So what is A value is greater than or equal to 1, B value is greater than or equal to 1, C value is also greater than or equal to 1, D is also greater than or equal to 1. Then you add and square it, you will be getting A square plus B square plus C square plus D square. Sum of square of 4 positive integer. A is one positive integer, B is another positive integer, C and D is also the positive integer. So A square plus B square plus C square plus D square is given. Sum of square of 4 positive integers. And I can also write A square is also greater than or equal to 1 by principle of arithmetic, or the property of arithmetic says that If a greater than or equal to 1, then I can say that a square is also greater than or equal to 1. Similarly, b is greater than or equal to 1, b square is also greater than or equal to 1. Similarly, for the other cases of c and d. So therefore, my x value will be x is greater than or equal to 4. Sum of square of 4 positive integer is a 1, b is also 1, c is also 1, d is also 1. The minimum value is 4. So let me take all together as x. X is equal to a square plus b square plus c square plus d square. Then the value becomes the minimum value as 4. X is greater than or equal to 4. So what is our conclusion? By conclusion, what I have to prove? 2 to the power of x is greater than or equal to x square. We already proved in the theorem 1 that if x is greater than or equal to 4, then 2 to the power of x is also greater than or equal to x square. So by that theorem, we can prove that the sum of square of 4 positive integer is also true. Is true for the case 2 to the power of x is greater than or equal to x square. So this is the proof by deduction. So all this using 4 square integers, a square plus b square, the sum is at least a minimum value is 4. Next. So these are the things that I told. By using theorem already we have proved that x is greater than or equal to 4 means I can prove that 2 to the power of x is greater than or equal to x square. Proof by induction. So the next proof is proof by induction. This is known as mathematical induction, inductive proof or something like that. Okay, so various names for mathematical induction. Inductive proof. What is a mathematical induction is if f of s of n is true, then s of n plus 1 is also true. So if this is the case, then I can say this is a mathematical induction. The induction hypothesis says that if s of n be any statement, then I have to prove s of n plus 1 is also true. So this can be done using 2 steps. Mathematical induction can be done using 2 steps. One is known as basis, the other one is known as induction. The basis step, more primitive values are given. The minimum value should be given for the value of the statement or any x value or any value. Some primitive values are given ranging between 0, 1 or 2, something like that. All these are integer values. Right? Then s of n plus 1 is also true. I have to prove basis is true. Then I can prove that s of n plus 1 is also true. This is done using inductive step. Right, next. So inductive proof always deals with integers only. Next. So we have taken one example. Summation of I is equal to 1 to n, I square is equal to n into n plus 1 into 2n plus 1 divided by 6. So this I have to prove using proof by induction, inductive step. So first one, 2 steps are there as I told, basis and induction. The first is basis. Let us take the left hand side of the equation given. Summation of I is equal to 1 to n I square. So in that, what is the statement given? Summation of I is equal to 1 to n I square. So n value should be taking some minimum value for the basis step. Let me put n is equal to 0 or I can put n is equal to 1 also. In this basis, let me put n as 0. What happens when the n value becomes 0? When the upper value is 0, I can make the entire term as 0. Whenever the upper limit is 0, I can make the entire term as 0. So the LHS now becomes 0. Next, consider the right hand side of the statement. Put n is equal to 0. N into n plus 1 into 2n plus 1 divided by 6. In that, when you put n value as 0, the RHS also becomes 0. LHS equal to RHS. So both the values are 0. Now I can say that basis is true. Now we go for inductive step. So what is induction? We have to prove the inductive step by using n plus 1. So we have to substitute instead of n as n plus 1. Substitute the value of n plus 1 first of all in the left hand side of the equation. Summation of I is equal to 1 to n I square. So in that I have to put substitute n value as n plus 1. What happens when n value as n plus 1? Now it becomes summation of, I can split it and write. This is summation of I is equal to 1 to n I square plus n plus 1th term. N up to n values, it is summation of I is equal to 1 to n I square. What about n plus 1? Summation of I is equal to 1 to n plus 1 will become summation of I is equal to 1 to n plus 1 the whole square. That is n plus 1th term is added at the end. now this can be written as, already I know that summation of I is equal to 1 to n I square as n into n plus 1 into 2n plus 1 divided by 6. I know that the basis is also true. Therefore, I can put n into n plus 1 into 2n plus 1 divided by 6 instead of summation of I is equal to 1 to n I square. So plus n plus 1 term is n plus 1 the whole square. So now I have to simplify this term. So first I have to simplify n into n plus 1. Next step, n into n plus 1 into 2n plus 1. See, n into n plus 1 will become n square plus n. So it is then multiplied with 2n plus 1 to give 2n cube plus n square plus 2n square plus n divided by 6 plus n plus 1 the whole square, that term. So now you have to simplify this. 2n cube plus 2n square plus n square will become 3n square. 2n cube plus 2n square, 2n cube plus n square plus 2n square plus n. Take LCM for these two terms. That is 2n cube plus n square plus 2n square plus n divided by 6 plus n plus 1 the whole square. When you take LCM, now it becomes 6 into n square plus 6 plus 12 into n. So now you simplify this. 2n cube plus 9n square plus 13n plus 6 divided by 6. So this is one answer. Further it cannot be simplified. You leave as such. Now take now we have took the left hand side of the equation and now we have substituted n value is equal to n plus 1. Similarly, we have to take right hand side of the equation and substitute n plus 1 instead of n. Thereby I should get the same value 2n cube plus 9n square plus 13n plus 6 divided by 6. So let us now consider the right hand side of the equation. Consider the right hand side of the equation, n into n plus 1 into 2n plus 1 divided by 6. In that I have to substitute n as n plus 1. So all the n value will become n plus 1 here. N plus 1, n plus 1 plus 1, 2 into n plus 1 plus 1. So n plus 1 into n plus 2 there, and that term will become, third term will become 2n plus 2 plus 1. So it is now 2n plus 3. In the next step it is becoming 2n plus 3. When you simplify n plus 1 and n plus 2, n plus 1 in n into n square plus 2n plus n plus 2. So again we have to simplify this to get n square plus 3n plus 2 multiplied by 2n plus 3. So when you again simplify this, n square multiplied by 2n plus 3 into n square plus 3n multiplied by 2n, 3n multiplied by 3 plus 2 multiplied by 2n, 2 multiplied by 3. So totally you will be getting 2n cube plus 3n square plus 6n square plus 9n plus 4n plus 3 divided by 6. That is equal to 2n cube plus 9n square plus 13n plus 6 divided by 6.